Okay, so here's the rules for naming basically a large variety of compounds. By the way, elements are not included here. Elements, you just call them by the element that you've seen on the periodic table. Okay, so you have a compound, and let's say that it is ionic. That is, that you have a metal and nonmetal, or you have polyatomic ions somewhere within that compound. Then you will be naming it with the cation first. Generally, that's going to be the metal, except for if you have ammonium. And then you'll be naming the anion. It's very simple. Name the cation, then name the anion. However, if your anion is a monoatomic ion, for example, if it were F minus, then it would end in ide, so it would be called fluoride. So a good example for all this is, let's say that you're dealing with this compound here. So you know that this is an ionic compound because you have a metal here, and you also have a polyatomic ion. Oh, you have an ion here, it must be ionic. Now, you can call it then just calcium, so you're naming the cation there, and then name this anion. Now this is known as hydrogen carbonate. That is a polyatomic ion. Alright, so next, what if you have an ionic compound though, and instead of having only one possible charge, there are multiple possible charges for your cation? Well, if that's the case, you're following the same rules as before, except you need to identify the charge on your cation, and so you'll be using Roman numerals to identify that charge. So let's say you were dealing with FeCl3. Iron is one of those transition metals which can have multiple charges. Additionally, lead and tin can have multiple charges. And so when we name this, we were going to call it iron. So we're naming the cation first, but then because iron can have multiple possible charges, we're going to say that well, this is iron 3. And then we'll call it chloride. It'll end in ide because we're using a monoatomic anion. How do I know that the iron here is iron 3? I guess you can use a little bit of algebra. You could say, hey, there's 1 of some unknown charge combining with 3 chlorides. Each of them has a -1 charge. And they're combining to give an overall charge of 0. You don't see an overall charge here, so they all combine to give 0. And so algebra gives us x minus 3 is equal to 0, i.e. x is equal to positive 3. So that's why we call this iron 3 chloride. Okay, now sometimes if we just have nonmetals, then we will say that we're dealing with a molecular compound. Now, there were some specific rules given in the last video in naming acids. So those are just entirely different rules. Also, we'll probably have a video on organics, that is, compounds with carbon in them that are molecular. So those have their own rules. But if it's not an acid or an organic compound, then it just follows this basically simple rule. You want to name the elements as you go from left to right, and you want to use prefixes to identify how many of each element there are. And so, you'll use prefixes, except though, if your first element, there's only one of it, then you will not be using mono. It will just be presumed. So you'll name your first element, and then a second, and then a third, and at some point you have your last element, and that last element ends in ide. Okay, so here are a bunch of prefixes here which you need to memorize. Okay, so let's go ahead and try to name SO3. SO3, well, that is going to have us naming just first the sulfur here. Of course, because there's only one of this leftmost element, this first element, I do not need to say mono. And so I'll just call it sulfur. And then I will say that there are oxides here, because oxygen is the last element here. However, we need to say how many oxides there are. You see that there are 3, so we'll call it sulfur And when there's 3, we use tri. Sulfur trioxide. What if we were using or naming S2F10? Well, then we would need to say how many sulfurs there are. It's disulfur. And then how many fluorides there are. It's 10. Now 10 will be represented by deca. So we'll say decafluoride. Okay, and I guess finally, what if we were dealing with O2? Well, then that is not a compound. That's just one element together, and so we'll just give it its normal elemental name. We'll just call that oxygen. All right, I guess I would just like to throw out one more example, and that other example is S2O5. So you might want to call this disulfur pentaoxide. However, we do not use 2 vowels next to each other in cases like this, and so we need to get rid of one of those vowels, and so we'll call it disulfur pentoxide. So you'll keep the O and you'll get rid of the A. Thanks for watching, guys.